Bismillahirrahmanirrahim. Assalamu alaikum, dear students. Welcome back in lecture 7. Student, basically lecture number 5 and 6 we covered the analysis portion of our flat slab system, and now we are in the design stage. Okay, so basically let me uh, discuss the example. Okay, so we start this example. Basically we ends the EW analysis, EW frame analysis, both for interior and exterior frame. Similarly, we start the NS frame, okay, and NS direction, sorry, for interior and exterior frame, okay, and then we complete the analysis and we show basically the movements. Now for design purposes, basically all the movements which we calculated, now what we need, we have to represent them, okay, like you see here, we have to categorize all the movements because we have to design for maximum and minimum movements, okay, and we have to determine where we have to provide which amount of reinforcement, okay. So design is a very simple process. The main and the key process is the analysis process. If your analysis is strong, design is nothing, it should be remembered, okay. So here I am making my categorization of movements like in this way. You see my A movements basically are those movements which is 28.3 and less than 16.8, okay, and my B movement which is less than 16.8 but in between 11.87, and C movements are those which is less than from 11.87. Clear? Now we will design for A movement. So for if my A movement is 28.3 feet per feet, so let's say I'm using number 5 bar. So if I'm using number 5 bar, I need spacing, okay. If let's say I'm using here head to trial rule, okay, you can easily use the formula which I have already used in my previous lectures, that A is 0.85 FC prime divided by Fy and so many other terms, okay. So that formula is easy to use, okay. But let's say we will using head to trial rule. You already know AS is equal to mu or ma divided by 5 Fy into d minus a over 2. You have to assume the A value, that is 0.2 times of your h or your effective depth. Now your A will be 1.7, just inserting the A value, you got your AST is this one. Then again revise the A value from this equation, you got 1.2, and again insert this A value in this equation, you got your AST value, that is 0.80. I think so you will understand this method, and this is the most basic approach which basically in ACI we will adopt it, okay, in our basic academic career. Although the formula which I have written and the procedure which I have explained, this is professional procedure, okay. We do this in field. So once I again my revise my A, I got 1.17, which you can say very close to 1.2, and that I stop my head to trial rule, and let I will say this is my AST. Now so you have to just insert the value of AST here, and you got your spacing, that is 4.5. My final design will be number 5 at the rate of 4 in center to center. Similarly for B, you can use the same procedure, assuming A value, inserting the A value again in the equation. This is trial 2, okay, this is trial 1, okay, and from trial 3 you got your AST value, the 0.46 and 0.46, so it coincide. Now determine the spacing 7.8. Let's say I'm using number 5 at the rate of 7.5 in center to center. Similarly for C, the same procedure you will adopt it, and you got the spacing, that is number 5 at the rate of 11 in center to center. So this is the procedure, that how you can do analysis for all those your movements. Now you got an idea that what is amount of spacing I needed, what will be my number of bar, okay. Similarly do the same procedure for NS direction movements, and first of all you need to categorize your movements. You have to write down your movements, and remember you have to choose measure values. How you can to choose and how you can to finalize your movements, okay, I will show you later. But here you see for this movement I will use bar A, bar B, and the bar B spacing, you see here the bar B movement is this one, okay, and similarly bar A movements will this one, bar C movement will this one, and bar D movement will be 6 and below. Similarly I do the work as I already mentioned, and I got for A movement number 5 at the rate of 6 inch into center to cover this movement, okay. But remember this is in inch direction, not in EW direction, okay. So in EW direction A is 4.5 inch or 4 inch center to center, but here we got 6 inches. Similarly for B 9 inches, 12 inches and 15 inches. This is the maximum spacing. Lastly and finally you have to check for minimum and maximum spacing. So maximum spacing is the same 2HF and the maximum spacing is 20 inch, okay. A is minimum you have to determine, and that is 0.216 inch square. And let's say you have to check your C and D reinforcement, that whether it is below or above A is minimum. So once you check, okay, you got AST for number 5 at the rate of 12 inch into center 0.30, and you know 0.3 is more than 0.21, so that means our C moment is also you can say AST, which is calculated for C movement, is greater than AS minimum. So ductility will be okay, ductility check will be okay. And similarly for D movement we got 0.21, which is also more than 0.24. So this means that number 5 at the rate of 15 inches center to center bars we will be used, okay. The code allow us here to use such an amount of spacing, okay. So this is very interesting, okay. We can use 12 inch, we can use 9 inch, we can use 15 inch as well. So this is the end of design, okay. Now I'm show you that how you have you will categorize your movements. So this is my NS frame. I have basically write down all the movements which I got, okay. And here you see these are the column. This yellow color basically representing the mid of the my middle strip, okay. Remember this is my middle strip from this line to this line. This is my middle strip, and this is again my column strip for my interior frame, and this is my basically is my column strip for my exterior frame, but it in its direction. Remember this is MS middle strip, this is column strip, and this is also column strip, remember, okay. Now in basically in this direction I round all the movements, and I have minus 11, okay. I write down it from here. You see here what I got the moment 10.4. I round it, that let's say this is 11, so I write down here 11, clear. Similar 12.3, you see 12.3 can be rounded 12.5 or 13, okay. And 20.69 I rounded, that is let's say this is my 20, or you can say this is my 21. It should be 21, okay. It should be 21, okay. This should be 21, clear. Similarly plus 6, so plus 9 I round it, and let's say this is my plus 9. Similarly here I have 19, okay. I write down 20, around it, okay. Similarly 12.3, and similarly those values again will be repeated. Similarly for middle strip you have to only write the maximum values. Here you see in its direction you see 0 and 0, so 0 is remain, 6 and 8.8. I just write 8.8, I ignore 6, okay. So that's why you see I write 8.8 is close to 9, okay. Similarly here from these 4 values you have to choose only one value, one maximum value, and you have to design only for that movement, that is 5.13. so I write down just minus 5, okay. And remember these are my negative movements, these are my positive movement, these are my negative movements. This is my positive movement, this is my negative movement, this is my negative movement, remember. Similarly this is my positive movement, 4.12 3. I just choose 4, okay. So here I write down 4. This plus sign means these are positive values, okay. And then you see here 19.4.76 I write down, this is 5, and 4.6 and 4.7. So I write down just 5. Okay, and you see here minus 5. Okay, and again those values will be repeated. Okay, the same values will be repeated, the above values will now be repeated. Similarly, if I write down the same values here, minus 11, minus 11, 12.3, already you know, you see here 11, 13, 22.1, let's say 21, 8.88, let's say 9, 20.6, let's say 21. So you see here 11, 13, 22 plus 9 minus 21. Now again those values will be repeated, plus 9, okay, 21, 22, sorry, this is exterior panel, so that's why this value will be written. And similarly again the procedure will be repeated, this 0 plus 9 minus 5 plus 4, the middle strip movements will be written down on the yellow color. And similarly this one will be again repeated, and similarly this one will be again repeated, and so on, you will reach to your exterior frame. So this is all about the inner frame. Okay, if let's say I will show you this corner frame movements in diagrammatically or graphically, if I want to represent this in, okay, so how it will be looks like. If you see, this is a 3D representation, and here you see there is only one in its direction. This is in its direction. So minus 10.4, I write down, let's say this is my 11. So 11 will be negative, then it comes down and becomes positive, and then it comes up. So this movement can be rounded, let's say this is 21, and here we have 12.32. So this is minus 11, 12.3 and 20. Okay, so this is the graphical representation. Similarly 0, 8.8 minus 5.13, you see here 0, 8.8 is rounded, that is 9, and minus 5. Okay, so this is the graphical representation. You must understand this, what these movements mean. Okay, this is positive, this is rounded, this is 9. Okay, so I designed reinforcement just for this movement in the middle strip, and I will design steel reinforcement for this movement in, and I provide that steel in within the column strip, not in the middle strip. Similarly, I will design for this and provide within the column strip. Remember, within the column strip, like in this strip. In this strip I will provide those bars. Okay, similarly you can show all these movements on this kind of arrangement. Okay, you can draw lines and showing them. Okay, and then because once you represent the movements in this shape, it will be then easy for you for which movement you have to design, which one movement is your maximum one. Okay, so this is easy for best understanding. Similarly in east west direction, let me show you east west direction, how I categorize the movements. This is my east west direction, and where I have got these movements, let me show you those movements, where those movements are. Okay, here. So 13.26, you can round it, let's say this is 14, or let's say this is 13. So I round, this is minus 14, and remember this is minus 14, this is minus, this is again positive. I write down this is 16, so let's say this is 16 plus 16. Similarly 26.8, 25, I round this movement, and let's say this is my minus 27. So this is my minus 27. Okay, again this movement, and this movement is you see here 10.75, this is positive. So I write down as a rounding and plus 11, and similarly again this movement will be now repeated. You see 25.1 minus 25.1, and I have minus 25. Okay, this will be again here, and this will be again. So this is my exterior and the first interior support, so that's why this first interior movement will be right down here, and again that movement will be here, and that movement will be here. So this is the way of representation. Okay, similarly for this magenta color, basically representing the middle strip. Now remember, this is my middle strip, this is my exterior strip. Remember, this is my exterior strip, and no, this is, remember, there is a line. Okay, that is your exterior column strip. This is one will be your exterior column strip, and this one, okay, this one will be your middle strip. This is important. Okay, and that one will be your column strip. Okay, so again I have 0 value, so you can confirm it. 0, 11.87, like let's say this is 12, 10 and 9.2. I select the maximum one. This is minus 10, this is plus 12, this is plus 8, and again I will write down this moment here, plus minus 10. Okay, so you see here, plus 12 minus 10 plus 8 minus 10 plus 8 minus 10 plus 8 minus 10 plus 12. Okay, this is the way. Similarly, the next line of column, so again I have the same movements with a little bit variation. Minus 14, I have minus 14. I write down this is minus, this is positive 17. Here again I have minus 28. Okay, this is maximum value. Similarly, plus 11, and similarly I can write this is minus, this is minus 26. Okay, so you see minus 14 plus 17 minus 28 plus 11 minus 26 plus 11 minus 26, 11 and minus 28 will be again repeated, 17 and minus 14, and again those values I write here. So this is similar for all these columns. You just repeat these values. These values will be shifted here. Similarly, these values will be shifted here. Okay, and these values will be shifted to this frame. Okay, and the last row values will be shifted to here. Okay, now after that we will determine, although we did the analysis design for it, but this is the diagrammatical show of bars representation, and I will explain this in next lecture. These are the cross sections. Okay, and one thing you must make sure here, this is very important diagram. You see, this is about for each panel. Each panel is which panel? Okay, let me show here. Each panel is basically your this panel. Okay, this panel is your edge panel, and this is your corner panel. Okay, this is your corner panel, and this one is your this one is your interior panel. Okay, so you must understand which one is your corner, and that one basically your edge panel, corner panel, sorry, this one is your corner panel. Okay, and now this one is basically my edge panel. Okay, this one. So in each panel you see minus 19.2, where is this 19.2? So let's see this one, minus 20. This is my 19 point, I rounded. Okay, and then again I have plus 16.8, or let's say 17 or 16. Okay, so here we have where this is north south, and in east west direction basically I need it. Okay, where is east west direction? This one. So plus 16, then again minus 27. You see here minus 27, minus 28. Okay, this is rounded. So you see this kind of, now the bars which is basically designed here in east west direction, you see this amount. A bar will be provided for 28 to 16. This means I have to place A bar will be here. Similarly, 28 to 16, A bar will be here, and plus 16. So you can provide B bar for this 16.8, and you check the capacity whether it work or not. Okay, I will show you inshallah how whether it work or not. Similarly, C bar can be provided for a movement which is less than 11.8. So you can remember these movements are in its direction. Okay, this minus 14 is basically it is chosen from the north south direction. Let me show you north south direction. This here we have, this is north south direction. Okay, so in north south direction, whether this minus 4, this is not minus 14, remember this is minus 19, minus 14 in east west direction, and minus 19 in north south direction. Okay, so that is basically north south direction. So here you see minus 19.2, and similarly this 8.27 you see here 8.27, and similarly this minus 19.2, so minus 19.2, and this is the basically graphic representation. So here I have to place bar in bottom layer, where here I need to place the bar in topward direction, in top layer, or you can say in top surface of the slab. Similarly, I have to provide bars in top layer, and here I have to provide bottom. Similarly, you can confirm these movements as well from this, okay, from this diagram. You have 4.76, 4.12 and 4.76. So you see here basically minus 5.13, the maximum value is taken. Here again 4 point, and here again minus 4.76. Similarly, minus 20.6 you can confirm from these 20.6, 8.8 and 20.6, and you see 20.6, 8.8 and 20.6. okay, so this means I have to place bar for this movement in this direction, I have to place bar for this movement in this direction. So basically these two bars cross now, and remember in the top portion. Then again I have to need, this is positive movement, so I need to place bar in downward direction of the slab and down surface of the slab, and for that movement 20.6 I have to place bar in this direction, but for 28 as it is longitudinal direction, so I have to place bar in this direction. okay, one thing is very important, 28 movement is maximum. okay, 28 movement is maximum. This means in the longitudinal direction movement is maximum, so that is negative movement. This means that you have to place bar in top portion. Here you have to place bar in top portion, okay, to gain the maximum. Let me show you the bar placing. okay, let's say this is my continued slab, and to that side it is also continued. So to cover 28 movement, I have to place the bar in longitude in the top portion. okay, remember this is opposite, the placing of bar basically opposite as the traditional way we did basically the slab reinforcement, that the shorter bar should be in bottom layer while the longer bar should be in top layer. okay, you already know that, but that is the case for beam slab supported. But in flat slab system I will share you that ACI code provision as well. okay, that what ACI code says about this, okay, where you have to place the bars. Now let me show you here detailing of flexure reinforcement. You have to provide that cover. Remember this sentence is very important. It says, in case of two-way slab supported on beam, short direction bars are normally placed closer to the top or bottom surface of the slab with the larger effective depth. This is usual way of placing the bars. But in flat slab system, this thing you see here the bars is in downward direction, but here you see the bars are in upward direction. Why? Here is a however, in the case of flat slab system, the long direction negative and positive bars, the longer direction negative and positive bars in both middle and column strip are placed closer to the top or bottom surface. Place here they are closer to the bottom, here they are closer to the top of them respectively, with the larger effective depth because of greater movement in longer direction. This remember that mostly this why I did this kind of representation, to show you the variation of the movements, that basically the higher amount of movement is transferring in longitudinal direction, in longer direction, and the lesser amount of movement is transferring in the shorter direction. So this suggests that you have to place your bars which is provided for the longer reinforcement, or you can say for the longitudinal movements, near the top surface or near the bottom surface. Mean that this is my main bar now for 28, which will be close to the top surface. okay, now 16, this is round about 17. This is the maximum movement which is transferring in the longitudinal direction. So that why I have to place bars. If I am placing here, I will place it near the bottom surface, and then the transverse bars which is coming from that direction will be looks like in this shape. okay, this shape I will discuss inshallah. And similarly for this movement I have to place bar here. okay, but you see this negative movement, to support this negative movement, this bar should be in the bottom like you see here, while the bar which is placed for this movement will be in this direction, remember, and they will be placed in the top portion. Similarly, for this movement, you have to place the bar in top portion, while in this movement, you have to place the bar in top portion and they cross each other. Okay, similarly, the bar will be in bottom, okay, because this is transverse, and for this there will be no need of reinforcement, but we provide minimum reinforcement. Okay, similarly, you see here there are two positive movements. So one bar will be in this direction and downward, and one bar will be in this direction and downward, but this bar should be in down portion, while that bar should be in above the bottom bar. Okay, this is important to understand. And similarly again, for this positive bar will be in downward direction, and for that movement the bar will be in top portion of the slab. And similarly here, one bar will be in this direction, one bar will be in this direction. I will show you very clearly, and you see the whole representation, how I represent the bars. The blue bars my in east-west direction, while the black bars my in north-south direction. So this is very important, and the next lecture inshallah I will show you the whole detail, okay, the cross-section detail, and I did all the calculations how to place the bars inshallah in very detail. You will understand completely. See you in next lecture. Thank you.